All right, folks, it's Bass Action, back in action here. In this video, we are going to go through our last method for solving a triangle. Remember, solving a triangle means finding all the parts of a triangle. Now, our last method is going to allow us to find missing parts when we do not have a link. So as you recall, with our right triangles, we can use SOHCAHTOA. If it's not a right triangle, but we know the measure of a side and an angle across from it, we can do law of sines. And now we're going to learn law of cosines. I will be reviewing law of sines in this video as well. So let's first jump into our law of cosines. Now, when you look at these formulas up here, I don't want you to feel too overwhelmed that these formulas look really, really complicated. I'm going to show you how to break these formulas down without having to memorize 3 separate formulas and all these different variables. This particular layout of the formula is going to allow you to find an angle. It will be easier for you if you do have the pattern down for both angles and sides. The next video will cover sides. So let's jump into how we would use this formula, how we can break this down into an easy way to find an angle. When you look at the formula, what I want you to notice is that in the numerator of this crazy looking fraction, we're just going to ignore the other two because they're just different variations of the same thing. So we're going to focus on just one, and we're going to notice in the numerator that I have these two sides, B and C. And in the numerator, I have those two values that I'm going to square, but in the denominator, I have those same two values multiplied together by 2. Now, what's important for us is that we are going to refer to these two pieces right here, these two sides that we square in the numerator and add and multiply together by 2 in the denominator. I am going to refer to those as your piece fingers. So as you go through this video, you're going to want to be thinking about the piece fingers, okay? It's going to allow you to do these without having all these variables. So let's look at our first problem here. We have Amy is playing field hockey. We're going to assume Amy is phenomenal with math. She's super quick thinking, and she sees that the field hockey goal is 12 feet wide. Okay, so Amy's going to be somewhere out here, and she's going to make a shot on goal, and she's going to very quickly estimate that her distance to one of the goalposts is going to be 45 feet. And then she's going to estimate, again, she's super quick with math in her head, she's going to estimate that her distance to the other one is 37 feet. Okay, now what Amy wants to know, because again, she's amazing with math, is she wants to figure out what is her angle for her shot on goal. Now, we would look at this and we'd say it's not a right triangle. You could verify it with converse Pythagorean theorem. We would say, hey, we don't have a link. We do not know the measure of an angle and the side across from it anywhere in this triangle. So we would be stuck with having to find a new method. Our new method is law of cosines. So what we're going to do is you're going to take your piece fingers, and I really do mean take your piece fingers, your first 2 fingers, and you're going to put one of your fingers on 37. You're going to put the other finger on 45. And when we set this problem up, what we're going to do is we're going to say cosine of A, because angle A is what we want, and then we're going to give ourselves a big fraction bar. And in the numerator of our fraction, we are going to take where our piece fingers are, because they're on each side of this angle that we want. Your piece fingers go on each side of the angle that you want, and you're going to take those piece finger numbers and you're going to square them and add them together. So 37 squared plus 45 squared. Doesn't matter which order you write them. In the denominator, you're going to take those same 2 piece finger numbers and you're going to multiply them together by 2. Now, the last thing we're going to do is we're going to say, hey, we never did anything with this third side. It's across from the angle that we want, and we're going to subtract that square. Okay? Now, when you type this in your calculator, here's what I would do. So if you've got your calculator there at home, I want you to type this along with me. And what you're going to do is you are going to type in this whole numerator, 37 squared plus 45 squared minus 12 squared, and then press enter. So you're going to specifically press enter. After you press enter, this is where it's really important, you are going to put a parentheses, Okay, so you're going to press, you're going to press enter and then divide for this fraction bar. Then you're going to do a parentheses and your multiplication and your multiplication. Do not retype these parentheses. You're going to do your little multiplication symbol and then you're going to press enter. Once you get that funky decimal, you are going to do your inverse cosine of whatever that decimal was. So whatever decimal you had there, you're going to do your inverse cosine and you should be able to get the measure of the angle is 13 degrees. Now, if you struggle getting this, don't worry. We'll be able to help you in class with getting that in your calculator. The most important thing is that you understand how to set up the problem. The next thing that I want you to notice on this particular problem is that if we put this 13 degrees back into the problem, we are tempted to say now, oh, there's a link. So if the problem asks you to find either of these other angles, there's a temptation to want to use law of sines now. Do not do that. And we're going to look at an example down here to show us why we do not want to switch from law of cosines to law of sines. So the way I tell my students to remember this is that we are going to remind ourselves to always start and end with the same law. So if you started with law of cosines, you have to do the whole problem with law of cosines. So let's take a look at this example here, and we're going to do it with law of cosines, and then we're going to see how it can go wrong. So very quickly, we're going to do this one more time. We're going to look at a triangle. We're going to find the measure of angle A. That means we want A. So our peace fingers are going to go here and here because A is the angle that we want. So we're going to say cosine A, and then we're going to give ourselves a fraction bar. We're going to take our peace fingers. We're going to square them and add them. We're going to multiply them by 2 in the denominator. And then we're going to subtract the square of the side across from the angle we want. So we're going to subtract 8 squared. Just like before, you're going to enter this whole thing in your calculator. Again, I would do a numerator, enter, divided by, parentheses, times, and then your enter. Again, you will have to use your inverse cosine. This is going to get us an angle measure for angle A. This is going to tell us that angle A is going to be approximately 22 degrees. So we're going to put that in our picture. Now, we're going to stick with our law of cosines because this is the proper way to do it, and we're going to see what happens here. So if we now want to find angle C, now these are the peace fingers. The angles on the sides on each side of our angle are the peace fingers. So now I want to say the cosine of C, big fraction bar. And again, if you're struggling with the calculator, don't worry. We can help you with that in class. We're going to say 8 squared plus 19 squared, because that's where our peace fingers are. 2 times 8 times 19. The side across from angle C is 14, so that's what we're going to subtract. So minus 14 squared. Practice with your calculator. You should get a value for angle C of 41 degrees. And then, if we go ahead and we do recognize that all the angles in the triangle add up to 180, we of course can just fill in our last angle for B and recognize that this is going to be 117. Okay, so now look at this question here. We look at our measures for our angle and do they make sense? Okay, biggest angle, biggest side, smallest angle, smallest side. Yay, these totally make sense. Okay, and that's what happens when you do law of cosines all the way across. Now, real quick, let's take a look and see what happens if you try to do the little switcheroo. You're going to see that sometimes this is going to fall apart on us, and you won't know when it's going to fall apart and when it's not. So from up above, we found that our angle A was 22 degrees, and that one would stay the same because remember, law of cosines would be the only way to find that angle. Now, if you decided to do this crazy shenanigan and switch, you would say, oh, look, I have a link. And if you try to do that and say 8 divided by the sine of 22, and then say, oh, well, I can find B by saying 19 over the sine of angle B. And we go through and we would set that up just like we've been doing so far. We would end up with the sine of b would be our 19, our sine 22, all over our 8. And if you type that into your calculator like we did in our last lesson, you're going to get an angle B of 63 degrees. Well, if angle B is 63 degrees, then that would make angle C 95 degrees, and this does not make any sense at all. The biggest side is no longer across from the biggest angle, and the whole thing falls apart. So, switching laws and switching to law of sines is not a method that you should do, because you could at any time end up with this crazy problem. You always want to start and end with the same law, and if you do that, you will always get the right answer. You won't have any crazy problems.